In this video presented by www.free-academy.com, we're going to practice our introduction of implicit differentiation by doing problems 9 and 10 out of the text. Notice I'm skipping problems 1 through 8 because I don't feel like there's any real value to doing them. So, starting out with problem 9, we're going to implicitly differentiate this. And, additionally, we're also going to solve for y and take the derivatives and show that they're both equal to the same. So let's start with the one that we know how to do. Let's solve for y and then find the derivative. And what we get is that negative xy equals 1 plus 2x minus x to the third. Then you can divide out the negative x and we get that y is equal to negative 1 over x minus 2 plus x squared. Now we can take the derivative of y with respect to x, and this is the same as y prime, and we get 1 over x squared minus 0 plus 2x. This is one of these points where I would recommend to go back and check out the derivative notation lecture. We have y equals f of x. So the derivative of y is the same as f prime of x, which is the same as dy by dx. You want to make sure you're familiar with all these different notations because they all have subtle little meanings to them that we jostle around a lot, and it can be very confusing to do implicit differentiations if you're not clear what all these have in common. Now that we've obtained that result doing the traditional method, let's do this by implicit differentiation. So we'll take the derivative with respect to x of both sides of this equation. And of course you distribute out the derivative to each term, just like we're familiar with doing at this point. And we'll need to use the product rule on the term x times y. But for starters, the derivative with respect to x of x to the third minus the derivative with respect to x of xy minus 2 times the derivative with respect to x of x equals the derivative with respect to x of 1, which is 0. So let's do the terms that we know how to do right away. The derivative with respect to x of x to the third is 3x squared. And the derivative with respect to x of x is equal to 1. So now we just need to find the derivative with respect to x of x times y. Now let me take this result and write it into the corner down here. Y prime is equal to x to the negative 2 plus 2 times x. So that way I can clear up some room here. And let's just find the derivative with respect to x of x times y. We'll call our x f, we'll call our y g. So f equals x. F prime is the derivative with respect to x of x, which is 1. G equals y. G prime is the derivative with respect to x of y, which of course is dy by dx, which is the same as y prime. The reason that the derivative of x with respect to x is equal to 1 is because, x is the variable. If you take the derivative of a variable with respect to itself, it's equal to 1. But y, we're saying that y is really a function of x. So there's more to it than just taking, if this was dy by dy, it would be equal to 1. But because it's dy by dx, it's the same as y prime, the same notational quirks that we've been using all before. So g prime equals y prime. So now we can plug this into our product rule formula, and we get that f prime times g plus g prime times f. And this is the exact same result that we got before in our introduction lecture. So this is all 3x squared minus y minus xy prime minus 2 equals 0. Alright, now that we've got that, I'm going to clear up some room again. Clear up all of this. And we didn't want to go that far. Alright, so we have our derivative 3x squared minus y minus xy prime minus 2 equals 0. Let's solve for our y prime. Y prime is going to be equal to negative 3x squared plus y plus 2 all divided by negative x. Now it may seem a little bogus, but just like before, we have to solve for y in our original equation so we can substitute it back into this equation. And in any practical implicit differentiation problem, you wouldn't be doing this. The reason we're doing it is just to check our results, that they're the same. So we had, what was it? Negative xy is equal to 1 plus 2x minus x to the third. So y is equal to minus x to the negative 1 minus 2 plus x squared. So let's plug that in, and we will get that y prime is equal to negative 3x squared plus minus x to the negative 1 minus 2 plus x squared plus 2 all divided by negative x. And I had the good sense to write that into the middle, so I'm squashed for room again. Let me change my color here. We have a minus 2 and a plus 2, so those will very clearly cancel. The x squared and the minus 3x squared will combine, so this will give us y prime is equal to minus 2x squared minus 1 over x all divided by negative x. So if you divide through the negative x, you now get minus 2 or plus 2x minus 1 over x squared, which of course is equal to x to the negative 2 plus 2x, which was exactly the result that we were looking for. So we did this problem explicitly and implicitly, and we got the exact same result either way.